Welcome to This Explainer. Today, we're diving straight into the mechanics of the mathematical world, algebra. Now look, algebra isn't just about shuffling letters around a page. It's actually a highly logical system designed for decoding real-world mysteries. It is literally the ultimate language of problem solving.
So think about it. How do we find an unknown quantity, especially when we're faced with two completely mysterious variables, but we only have two clues to go on? It's like a giant puzzle. Well, today, we're going to build your mathematical toolkit to solve that exact mystery.
Here's our roadmap for the explainer. 1. Solving simple linear equations. 2. Constructing equations from life. 3. Working with formulas. 4. Solving equations simultaneously. And finally, 5. The graphical intersection method.
All right, let's jump straight into Section 1, Solving Simple Linear Equations, the Math Detective's first clue.
Okay, as a quick refresher, an equation is formed specifically when the value of an unknown quantity is needed, right? It's basically a statement saying that two things are exactly equal. Whenever a crucial piece of information is missing from your reality, an equation is your starting point. It's kind of like the mathematical equivalent of drawing a chalk outline around a missing variable, our elusive x.
Now, check out this perfectly balanced scale. It represents the absolute golden rule of algebra. Whatever is done to one side of the equation, you absolutely must do to the other side. If you add a weight to the left, the scale tips. To keep that perfect balance, the absolute truth of the equation, you have to add that exact same weight to the right. Multiply one side by 3, you got to multiply the other side by 3. So maintaining this perfect mathematical balance is absolutely crucial. It's literally the only way to successfully isolate your unknown variable.
Moving on to Section 2, Constructing Equations from Life, translating the world into math.
Let's actually see how this works using a real physical shape, like a triangle. Say we have a right-angle triangle. We know that corner is 90 degrees, but the other two angles, totally mysterious. We'll call them x plus 30 and x minus 30. So, step 1 anchors us. We know interior angles always sum to 180 degrees. Step 2, we construct our equation by adding those angles together to equal 180. Step 3, we simplify. Notice how those 30s beautifully cancel each other out. That leaves us with 2x plus 90 equals 180. And finally, step 4, apply our golden rule. Subtract 90 from both sides, leaving 2x equals 90.
And simply dividing both sides by 2 reveals our answer, 45. Our detective work paid off. X equals 45. And you know the best part? We can actually check our work here. If x is 45, then x plus 30 is 75, and x minus 30 is 15. Add those to our 90-degree corner, and 75 plus 15 plus 90 perfectly equals 180 degrees. Boom! Case closed.
Which brings us to Section 3, Working with Formulas, Recipes for Reality.
So while an equation hunts down one specific missing number, a formula is much grander. A formula describes a relationship between different variables which holds true for all values of those variables. It's like a master recipe. It doesn't just bake one specific cake, it tells you how the cake will turn out no matter what specific quantities of ingredients you put in.
Just look at these incredible real-world anchors. The formulas we use every single day govern motion, nature, and even commerce. For example, V equals U plus AET calculates the final velocity of an accelerating car. If a car starts from rest, meaning its initial velocity, u, is 0, and it accelerates at 2 meters per second squared for 10 seconds, the formula tells us its final velocity is exactly 20 meters per second. Or take nature. Temperatures drop the higher you climb up a mountain. The formula, T equals base temperature minus height divided by 200, perfectly predicts the freezing point 5,000 meters up. From figuring out the area of a circle to calculating the final cost of your taxi ride with fixed charges, formulas are what allow us to map out reality.
All right, Section 4, Solving Equations Simultaneously, the two-clue mystery.
Sometimes life doesn't just hand us an x to find, it hides a y as well. This is where simultaneous equations come in. This is the process of solving two equations to find a common solution when the values of two unknowns are needed at the exact same time. You see, one equation alone with two unknowns, that gives you infinite possibilities, but two interconnected equations, they cross paths at one and only one shared truth.
To crack this, we basically have two main paths. The elimination method is exactly what it sounds like. We manipulate the equations to permanently remove one variable from the board entirely.
The substitution method takes a different route, rearranging one equation to isolate a variable and then plugging that entire expression into the second equation. Both are going to get you to the truth, but today we're really going to focus on the elegance of the elimination method.
Okay, let's walk through the mechanics. Step 1. Line up your equations. We've got 3x plus y equals 9 and 5x minus y equals 7. Now look closely at those y values. One is positive, the other is negative. Step 2 takes advantage of this beautifully. If we add these equations vertically, the y's completely cancel out. Eliminated. Adding the rest of the terms gives us 8x equals 16. Step 3, solve for x. Just divide by 8 and x equals 2. Final step, substitute that 2 back into the first equation. 3 times 2 is 6. So 6 plus y equals 9, which means y absolutely must be 3. So our shared truth is x equals 2 and y equals 3.
And that brings us to Section 5, the graphical intersection method, the visual proof.
To solve this graphically, we're going to need a graphic display calculator. But here's the thing, calculators don't natively speak the language of 3x plus y equals 9. We first have to translate our formulas into a format the calculator can actually plot. That means rearranging our equations to make y the subject. So 3x plus y equals 9 becomes y equals negative 3x plus 9, and 5x minus y equals 7 rearranges to y equals 5x minus 7. Once we do that, we can plug these directly into our device. And wow, this brilliantly illustrates the magic of mathematics. The second you hit draw, those abstract algebraic inputs instantly become visual. They literally manifest as intercepting geometric lines on a grid. The blue line here represents every single possible combination for our first equation, and the red line represents every possibility for our second. And that point where they cross, that is the one place in the universe where both statements are true simultaneously. Now we just let our tech pinpoint that exact intersection. Different tools have slightly different menus. Casio users will utilize Gsolve, then intersect, while Texas Instruments users hit calc and navigate to option 5. But either way, the calculator mathematically scans the pixels to find the precise coordinate where our two paths overlap.
And there's the aha moment. The screen shows the exact graphical coordinate, x equals 2 and y equals 3. Look at that. It perfectly matches our algebraic elimination solution. This is the ultimate visual proof that the mathematics we performed by hand is completely, undeniably sound. We translated a real-world problem into variables, used the golden rule of algebra to manipulate them, and proved it visually with geometry. How cool is that? Which leaves us with this final thought. We've seen how simple numbers and letters can perfectly map the exact intersection of two distinct paths, predicting where they'll meet with absolute certainty. So, I ask you, armed with these incredible mathematical tools, what other invisible, complex relationships in our universe could you decode next? The math is out there, just waiting for you to find the equation. Thanks for hanging out and learning with me today on this explainer. Keep questioning and keep calculating.